people still want to do. Um, okay, so when I say you can use multiple GPUs, and it's pretty easy to use in Icicle, and here's how you can use it. So what this line is doing is, it's let's say you have two GPUs. So all you need to do is you define a GPU device with an ID. So the second parameter is ID. So you start with 0, and then if you do with a new ID, it's going to basically give you access to a new GPU instance. Of course, you need actual two GPUs in the backend to be able to do something like this. But what I'm trying to say is, it's pretty easy to, from a developer point of view, just write as many GPU device instances as you want, and then use them. So you can use, let's say this particular GPU is configured to handle, let's say, sum check the best. So use this for sum check, use this for MSM of size 2 power 20, and then you can spin up another one. To do even more specialized things, or you can sort of decide, like in the code itself, how you want to distribute your workload. Yeah.
Is it mentioned the GPU device ultimately, or you can like choose which is which? Like I want the first device is maybe like 4090.
Yes, you can configure that exactly. So when you have this backend, you basically can configure what variable in your code corresponds to what GPU instance. So you can set that. You need to sort of set the environment variable correctly. Any more questions? So I think the entity example was just to demonstrate, like, even though Icicle provides like a very easy to use library to accelerate your operations, it is still important, very important, to know how to optimally use GPU. Like you can't just naively do all serialized operations on GPU. That's going to kill your performance. You also need to do some hand optimizations.
Sorry, just one more another kind of question. The grand scheme of things is to make sure that one of this library compiles down to a couple of environments like CUDA, Metal, and FTP, right? So this, I understand this may not have been realized yet for Metal and FTP.
Yes, it's work in progress. So yeah. So what new backend?
What's your take on CMD compared to Metal, for example, maybe CUDA, for example?
Yeah, so Metal, like, are you asking like why do we need to support Metal, or like what's special with Metal?
No, I'm wondering like, what's your take on CMD, or like any kind of support CMD,
SIMD? Yeah, so I, to be honest, like I won't be able to answer in technicalities, like, okay, like what, like how we are leveraging that. All I can say is, like Metal, we are mainly focusing for client side proving, to be able to generate proofs on Mac, because lots of applications require client side proving. Web GPU for the same reason, but in the browser. Yeah, so the way we have built the abstraction is uh, because we started bottom up, in the sense that we built like all the field operations, all modular arithmetic. Then on top of that, uh, group operations, point addition, Montgomery conversion, etc. Because we had like flexibility in building bottom up, uh, we were able to like realize that okay, maybe we can add new backends on top of uh, the low level abstraction that we have. So we didn't do anything like special, and maybe I'm not giving you the perfect answer. Probably the chief architect, one of my colleague Yuval might be able to answer that well. But yeah, because we did all these very low level operations, we were able to scale it to different backends. All right, so I think so far we have only been trying to run a few tests. So I guess we can take a break of. I'm told I have time till 5, so let's take a 20-minute break, and then we'll actually do the Rust examples. Actually do some playing around with Rust examples, if people want. Cool. Let's meet at 4 back here. Cool. Thank you.